Now there are so many parameters involved in this question. This will be done in a few steps. So the first step will be to determine the ratio of the speeds of A, B, and C. That can be determined by calculating how much distance B and C have traveled when A has finished the race. So using that, you'll be able to find out the distance traveled by A, B, and C, which will give you the ratio of the speeds of A, B, and C. Now, speed of A is given, we'll calculate the speed of C, and then we'll find out if A gives a t second head start to C in a kilometer race and finish the race t meters ahead. So in that scenario, what will be the value of t? All right. So the first element of this question, three friends, A finished the race 160 meters ahead of B. B finishes the race 160 meters ahead of C, and then the third relation is this. So let's use all these three relations between the distance traveled by A, B, and C to find out the ratio of their speeds. So I'll start by assuming that x is the distance of the entire race. So x is the length of the racetrack. So when A has traveled x meters, B will travel 160 meters less than A, and C will travel 304 meters less than A. Okay. Now in another race, if B finished the race 160 meters ahead of C, so if B will travel x, C will travel x minus 160. Okay. So now you can equate the distance traveled by B and C. So अगर मैं यहाँ पे equate कर देता हूँ and do the cross multiplication, you will get a linear equation in x because x square will get cancelled. Okay. So you will get linear equation in x square cancel हो जाएगा. So talking about that 320x minus 304x, that is 16x is equal to 160 multiplied by 160. Okay, so the value of x will be equal to 1600. So the length of the racetrack is 1600. So if A has traveled 1600, B has traveled 160 less than that, that is 1440. Okay, and I can say C has traveled 304 meters less than A, that is 1296. Okay, simplifying this ratio, this will come out to be 100 is to 90 is to 81. So this is the ratio of the speeds of A, B, and C. The speed of A is given as 40 kilometers per hour. I'll convert it in meters per second and we'll also find out the speed of C. Okay, so the ratio of the speeds of A, B, and C is 100 is to 90 is to 81. This is A, this is B, and this is C. Now, speed of A is 40 kilometer per hour. Multiplying it by 5 by 18, so it will be equal to 1000 upon 9 meters per second. Speed of C, A and C का ratio है 100 upon 81. So speed of C will be equal to 81 upon 100 times the speed of A, right? And it will come out to be 9 meters per second. I'm sorry, the speed of A will not be 1000 upon 9, it will be 100 upon 9. Okay, so 100 upon 9, and similarly here, it will be 100 upon 9. I think I said 100 upon 9, I have written 1000 upon 9, so 200 upon 18, that is 100 upon 9, and speed of C will be 81 upon 100 times the speed of A, so it will be equal to 9 meters per second. So these are the speeds of A and C that I've calculated. Now looking at the last statement, if A gives t seconds head start to C, so that means C has traveled t seconds more than A, okay, and finishes the race t meters ahead of C. So that means A has covered t meters more than C. So if A has covered 1000 meters, the entire race track, okay, this is a race of 1 kilometer. So time taken by A will be 1000 divided by the speed of A. Okay. Similarly, time taken by C. Now C, A has finished t meters ahead of C. So distance traveled by C is 1000 minus t divided by the speed of c is 9. Okay, this is the time taken by c. Now, time taken by c is t seconds more than time taken by a. So if I'll subtract t seconds from the time taken by c, I can equate it to the time taken by a. All right. Now, taking LCM on the right hand side and doing cross multiplication, you can solve for the value of t. So the value of t will come out to be 19. All right. This is what is asked in this question. So the value of t is 19 and that will be the correct answer.